We'll now take a look at the modern era, which takes place from 1950 to the present. The last 60 or so years have involved taking the von Neumann architecture and improving on it in terms of the hardware and the software. So development since 1950 has been more of an evolutionary process rather than a revolutionary process. So instead of trying to come up with new architectures, we're just improving on the already existing architecture. So with these changes, we're making computers faster, we're making them smaller, cheaper, more reliable, and a lot easier to use. However, the basic underlying structure has remained mostly the same. We haven't really had any drastic changes to this underlying structure. This time period is actually broken up into generations. So the period between 1950 and 1957 would be considered the first generation of computing. So this area actually saw the appearance of commercial computers. So the UNIVAC 1 and the IBM 701 were the first commercial computers. And the problem is, they were bulky, expensive, slow, and unreliable, even though that they used a similar design to the EDVAC. But they used vacuum tubes for processing and storage. They were extremely difficult to maintain. In fact, even the simple act of turning on a machine could actually just blow out a dozen tubes. They were that unreliable. So for this reason, these first generation machines were only used by trained personnel and were only used in specialized locations such as large corporations, governments, university research labs, military installations that could provide the expensive support environment. The second generation was considered to be around 1957 to 1965. And during this time period, we saw a major change in the size and complexity of computers. And this is because in the late 1950s, those bulky vacuum tubes were replaced by a single transistor. And these were only a few millimeters in size. And memory was now constructed using tiny magnetic cores. These were only 1/50th of an inch in diameter. So these changes dramatically reduced the size and the cost of our machines. Not only did we see changes in the size of the computers, but we also saw a change in how we communicate with computers. So we also saw the introduction of Fortran and COBOL, and these were the first high-level programming languages developed. And what was so significant about this is it was no longer necessary to be an electrical engineer to solve these problems on a computer, because now users would be able to write instructions. And this is where the programmer profession was created. The idea of shrinking down the sizes of computers continued in the third generation, which lasted between 1965 and 1975. This was considered the era of the integrated circuit. So rather than using discrete electronic components, we use integrated circuits with transistors, resistors, and capacitors, and these were photographically etched onto a piece of silicon. So these circuits together were what are called circuit boards. And as a result, we actually were able to take these computers that were the sizes of buildings and rooms and shrink them down to basically the sizes of desks, or even just be able to be placed onto desks, but they become much smaller. And as a result, we actually saw the birth of the first mini computer. And this was developed by the Digital Equipment Corporation, and this was called, and that actual mini computer was called the PDP-1. We also saw the birth of the software industry, because we now have companies that were writing software for computers instead of just research corporations and the government writing instructions. So in fact, by the mid-1970s, computers were no longer a rarity. They were being widely used in all sorts of areas. They were used in industry, government, military, and education. The fourth generation lasted from 1975 to 1985, and this is where we saw the appearance of the first microcomputer. So this was the Altair 8800, and this was developed in January of 1975. And the idea with the microcomputer is that we now had our circuit technology be so advanced that the entire computer system could be contained in a single circuit board instead of several circuits, and these boards were small enough to fit into your hand. As a result, these computers were small enough to fit onto an entire desk. So before we were talking about computers that were about the size of a desk, but now these were able to just be placed on top of desks themselves. This era was also the first, we actually got the first appearance of computer networks, electronic mail, or what we know as emails, graphical user interfaces or GUIs, and embedded systems. So we just saw more advancements in different components that we can include in our computers. The fifth generation takes place from 1985 to pretty much where we are today. In fact, in this era, things are changing so fast that the concept of distinct generations just doesn't really apply anymore, because change is just a constant companion, because we're just getting so many recent developments that it's very difficult to keep up. So I mean, yeah, I'll just go over some of the recent developments that we've seen so far in computing, but this is just a small drop in the bucket. I mean, in fact, by the time that you see this lecture, there could be even more advancements made in computing. But now we see things like parallel processors, where we would have a processor that would have multiple cores. So instead of being able to do just one instruction at a time, we can do multiple instructions simultaneously. We now have smartphones, tablets, and other handheld devices that are used. They're basically miniature computers that we can use for talking with people, playing games, doing programs, all sorts of things on here. We have high resolution graphics for imaging, for games, movies. So I mean, now a lot of our movies include CGI. Some may like it, some absolutely hate it, but we do have those high resolution graphics for entertainment purposes. We have powerful multimedia user interfaces for sounds, voice recognitions, photographs, and so forth. So we have different ways of handling multimedia. We have integrated digital devices for being able to incorporate data. You have these devices that are used for TVs, phones, cameras, that can handle the internet, the web. So we have all these different types of devices that have all these features. I mean, just going back to the smartphone, it is a phone that's also a camera that accesses the internet. It does all sorts of things. So we have all these different integrated devices that have these features. We have wireless communications. So I mean, now we can just connect to the network without the need of a wire. We can use it to do it wirelessly. And then we also have massive storage devices. I mean, think about how much stuff we could store in computers a long time ago. It may be only a couple kilobytes, maybe a couple of megabytes. Now we have like terabyte hard drives. Now we have cloud computing where we can store a whole bunch of stuff online. So the whole point is now we can store even more and more data on our machines.